Question 91. All Compute Engine instances in your VPC should be able to connect to an Active Directory server on specific ports. Any other traffic emerging from your instances is not allowed. You want to enforce this using VPC firewall rules. How should you configure the firewall rules? A. Create an egress rule with priority 1000 to deny all traffic for all instances. Create another egress rule with priority 100 to allow the Active Directory traffic for all instances. B. Create an egress rule with priority 100 to deny all traffic for all instances. Create another egress rule with priority 1000 to allow the Active Directory traffic for all instances. C. Create an egress rule with priority 1000 to allow the Active Directory traffic. Rely on the implied deny egress rule with priority 100 to block all traffic for all instances. D. Create an egress rule with priority 100 to allow the Active Directory traffic. Rely on the implied deny egress rule with priority 1000 to block all traffic for all instances. The best approach is option A. Create an egress rule with priority 1000 to deny all traffic for all instances. Create another egress rule with priority 100 to allow the Active Directory traffic for all instances. Explanation of why option A is correct. In Google Cloud, VPC firewall rules are evaluated in priority order, from the smallest number to the largest. To ensure only the required traffic to the Active Directory server is allowed, you can 1. Create a specific allow rule for Active Directory traffic with a higher priority, lower number, example 100. 2. Add a deny all rule with a lower priority, higher number, example 1000, to block all other egress traffic. This configuration ensures that only traffic allowed by the higher priority rule, Active Directory traffic, is permitted, while all other traffic is blocked by the deny rule. Analysis of other options. Option reason against. B. A deny all rule with a higher priority, 100, would block all traffic, including the Active Directory traffic, making the allow rule ineffective. C. The implied deny egress rule has the lowest priority, 65535, and is not configurable. Without explicitly denying other traffic, unintended traffic could flow. D. An allow rule with priority 100 would work for Active Directory traffic, but relying on the implied deny rule does not meet the explicit blocking requirement. Conclusion. Option A correctly enforces the requirement by explicitly allowing Active Directory traffic with a higher priority rule and blocking all other traffic with a lower priority rule. This approach is secure and adheres to best practices for fine-grained egress control. Question 92. Your customer runs a web service used by e-commerce sites to offer product recommendations to users. The company has begun experimenting with a machine learning model on Google Cloud Platform to improve the quality of results. What should the customer do to improve their model's results over time? A. Export Cloud Machine Learning Engine performance metrics from Stackdriver to BigQuery, to be used to analyze the efficiency of the model. B. Build a roadmap to move the machine learning model training from cloud GPUs to cloud TPUs, which offer better results. C. Monitor Compute Engine announcements for availability of newer CPU architectures, and deploy the model to them as soon as they are available for additional performance. D. Save a history of recommendations and results of the recommendations in BigQuery, to be used as training data. The best approach is option D. Save a history of recommendations and results of the recommendations in BigQuery, to be used as training data. Explanation of why option D is correct. Improving the performance of a machine learning model over time requires using more relevant and high-quality training data. By saving a history of recommendations and their results, the customer can 1. Capture user behavior and feedback, example whether a recommendation was accepted or ignored. 2. Continuously retrain the model with updated data to ensure it adapts to changing user preferences and trends. 3. Leverage BigQuery's scalability and analytical capabilities to process large data sets efficiently. This approach directly impacts the model's ability to learn and improve, leading to better predictions. Analysis of other options. Option reason against. A. Exporting cloud machine learning engine performance metrics to BigQuery helps monitor system performance but does not contribute to improving the model itself. B. Moving from cloud GPUs to TPUs may enhance computational efficiency for training, but this does not inherently improve the model's results. C. Deploying the model on newer CPU architectures can improve inference performance but does not address the model's quality or learning capabilities. Conclusion. Option D is the most effective solution because it focuses on gathering and using actionable data to enhance the machine learning model's accuracy and relevance over time. This aligns with best practices in iterative model development and continuous improvement. Question 93. A development team at your company has created a dockerized HTTPS web application. You need to deploy the application on Google Kubernetes Engine, GKE, and make sure that the application scales automatically. How should you deploy to GKE? A. Use the horizontal pod autoscaler and enable cluster autoscaling. Use an ingress resource to load balance the HTTPS traffic. B. Use the horizontal pod autoscaler and enable cluster autoscaling on the Kubernetes cluster. Use a service resource of type load balancer to load balance the HTTPS traffic. C. Enable autoscaling on the Compute Engine instance group. Use an ingress resource to load balance the HTTPS traffic. D. Enable autoscaling on the Compute Engine instance group. Use a service resource of type load balancer to load balance the HTTPS traffic. The best approach is option A. Use the horizontal pod autoscaler and enable cluster autoscaling. Use an ingress resource to load balance the HTTPS traffic. Explanation of why option A is correct. This approach aligns with Kubernetes best practices for deploying a scalable and reliable application. 1. Horizontal pod autoscaler. HPA ensures the application scales automatically by adjusting the number of pods based on CPU, memory, or custom metrics. 2. Cluster autoscaling dynamically adds or removes nodes in the cluster to accommodate the scaling needs of the pods. 3. Ingress resource provides a robust and Kubernetes-native way to handle HTTPS traffic. It allows for advanced features such as path-based routing, SSL termination, and integration with Google Cloud's load balancer for improved performance and reliability. Analysis of other options. Option reason against. B. While this option uses HPA and cluster autoscaling, relying solely on a service resource of type load balancer for HTTPS traffic does not provide the advanced features of an ingress resource. C. Autoscaling on Compute Engine instance groups is not relevant to GKE, as Kubernetes handles scaling at the pod and cluster levels. D. Similar to option C, this approach focuses on Compute Engine instance group autoscaling, which is not applicable for a Kubernetes-based deployment. Conclusion. Option A is the most suitable solution as it leverages Kubernetes native tools for scaling and load balancing, ensuring optimal performance, reliability, and adherence to best practices for deploying containerized applications on GKE. Question 94. You need to design a solution for global load balancing based on the URL path being requested. You need to ensure operations reliability and end-to-end in-transit encryption based on Google best practices. What should you do? A. Create a cross-region load balancer with URL maps. B. Create an HTTPS load balancer with URL maps. C. Create appropriate instance groups and instances. Configure SSL proxy load balancing. D. Create a global forwarding rule. Configure SSL proxy load balancing. The best approach is option B. Create an HTTPS load balancer with URL maps. Explanation of why option B is correct. An HTTPS load balancer with URL maps is the recommended solution for global load balancing based on URL paths while ensuring reliability and end-to-end in-transit encryption. This configuration adheres to Google Cloud's best practices. 1. Global load balancing. HTTPS load balancers are global by design, distributing traffic across backend services in multiple regions based on proximity, latency, and health checks. 2. URL maps. URL maps allow path-based routing, directing specific URL paths, example, images, API, to corresponding backend services or instance groups. 3. End-to-end encryption. HTTPS load balancers natively support SSL/TLS termination and re-encryption to the backend using HTTPS, ensuring in-transit encryption across all hops. 4. Reliability. Google managed infrastructure ensures high availability and automatic failover. Analysis of other options. Option reason against. A. While cross-region load balancers offer global load balancing, they lack the URL maps functionality necessary for path-based routing. C. SSL proxy load balancing supports SSL termination but does not provide URL maps for path-based routing. It is also less suited for HTTPS applications. D. A global forwarding rule with SSL proxy load balancing provides SSL termination but lacks the URL maps feature, which is critical for URL path-based routing. Conclusion. Option B is the best solution as it meets the requirements for global load balancing, URL path-based routing, and end-to-end encryption, following Google Cloud's best practices for designing secure and reliable applications. Question 95. You have an application that makes HTTP requests to cloud storage. Occasionally the requests fail with HTTP status codes of 5xx and 429. How should you handle these types of errors? A. Use gRPC instead of HTTP for better performance. B. Implement retry logic using a truncated exponential backoff strategy. C. Make sure the cloud storage bucket is multi-regional for geo-redundancy. D. Monitor https://status.cloud.google.com/feed.atom and only make requests if cloud storage is not reporting an incident. The best approach is option B. Implement retry logic using a truncated exponential backoff strategy. Explanation of why option B is correct. HTTP status codes 5xx, server errors, and 429, rate limiting, indicate transient issues or temporary unavailability. Google Cloud Storage recommends handling these errors by implementing a retry mechanism to ensure requests eventually succeed. A truncated exponential backoff strategy is particularly effective because 1. Exponential backoff gradually increases the wait time between retries, reducing the likelihood of overwhelming the server during periods of high load or service disruption. 2. Truncation limits the maximum wait time to prevent excessively long delays. 3. Best practice. This is a well-documented approach for managing transient errors in distributed systems and aligns with Google Cloud's recommendations for handling retries. Analysis of other options. Option reason against. A switching to gRPC may improve performance but does not address the root issue of transient errors. These errors could still occur with gRPC. C. Making the bucket multi-regional improves availability and redundancy but does not mitigate transient errors or rate limiting, which are unrelated to bucket location. D. Monitoring the status page is reactive and impractical for dynamic applications. Transient errors occur even when no incidents are reported, making this approach unreliable. Conclusion. Option B is the most effective solution, ensuring reliable application performance by gracefully handling transient errors and adhering to Google Cloud best practices for retry logic. Question 96. You need to develop procedures to test a disaster plan for a mission-critical application. You want to use Google recommended practices and native capabilities within GCP. What should you do? A. Use Deployment Manager to automate service provisioning. Use activity logs to monitor and debug your tests. B. Use Deployment Manager to automate service provisioning. Use Stackdriver to monitor and debug your tests. C. Use gcloud scripts to automate service provisioning. Use activity logs to monitor and debug your tests. D. Use gcloud scripts to automate service provisioning. Use Stackdriver to monitor and debug your tests. The best approach is option B. Use Deployment Manager to automate service provisioning and use Stackdriver to monitor and debug your tests. Explanation of why option B is correct. This approach aligns with Google recommended practices for disaster recovery planning and testing. 1. Deployment Manager for automation. Google Deployment Manager is a native infrastructure as code (IAC) tool that allows you to automate the provisioning and configuration of GCP resources. This ensures consistency, repeatability, and efficiency when setting up environments for disaster recovery testing. 2. Stackdriver. Now cloud monitoring and cloud logging provides robust monitoring, logging, and debugging capabilities to observe the behavior of your application during disaster recovery tests. It helps identify bottlenecks, misconfigurations, or failures in real time. 3. Integrated capabilities. Combining Deployment Manager and Stackdriver ensures a cohesive solution for testing and improving your disaster recovery procedures while adhering to Google Cloud best practices. Analysis of other options. Option reason against. A. Activity logs provide basic insights into administrative operations but lack the comprehensive monitoring and debugging features of Stackdriver. C. While gcloud scripts can automate provisioning, they are less efficient, scalable, and maintainable compared to Deployment Manager for disaster recovery scenarios. D. Gcloud scripts are not as robust as Deployment Manager for automating complex disaster recovery procedures, making this option less efficient. Conclusion. Option B is the optimal solution as it leverages Google Cloud's native tools to automate provisioning and provide comprehensive monitoring and debugging capabilities for disaster recovery testing, ensuring efficiency and reliability. Question 97. Your company creates rendering software which users can download from the company website. Your company has customers all over the world. You want to minimize latency for all your customers. You want to follow Google recommended practices. How should you store the files? A. Save the files in a multi-regional cloud storage bucket. B. Save the files in a regional cloud storage bucket, one bucket per zone of the region. C. Save the files in multiple regional cloud storage buckets, one bucket per zone per region. D. Save the files in multiple multi-regional cloud storage buckets, one bucket per multi-region. The best approach is option A. Save the files in a multi-regional cloud storage bucket. Explanation of why option A is correct. Google Cloud Storage's multi-regional buckets are designed to store data across multiple regions within a multi-region, example US, EU, Asia. This ensures 1. Low latency. Data is replicated across geographically dispersed locations, allowing users to access the nearest copy, reducing latency. 2. High availability and durability. Multi-regional buckets offer built-in redundancy, providing reliability and performance for global customers. 3. Simplicity. A single multi-regional bucket eliminates the need for managing multiple buckets, simplifying configuration and maintenance. This configuration is aligned with Google's best practices for distributing content to global users. Analysis of other options. Option reason against. B. Using regional buckets restricts data to a specific region, which may increase latency for customers located far from that region. C. Managing multiple regional buckets per zone per region adds unnecessary complexity and does not provide the global redundancy and latency benefits of a multi-regional bucket. D. Storing data in multiple multi-regional buckets adds complexity without significantly improving performance compared to using a single multi-regional bucket. Conclusion. Option A is the optimal solution as it uses Google Cloud's multi-regional storage to minimize latency, maximize availability, and simplify operations, ensuring a seamless experience for customers worldwide. Question 98. Your company acquired a healthcare startup and must retain its customers' medical information for up to 4 more years, depending on when it was created. Your corporate policy is to securely retain this data, and then delete it as soon as regulations allow. Which approach should you take? A. Store the data in Google Drive and manually delete records as they expire. B. Anonymize the data using the Cloud Data Loss Prevention API and store it indefinitely. C. Store the data in cloud storage and use lifecycle management to delete files when they expire. D. Store the data in cloud storage and run a nightly batch script that deletes all expired data. The best approach is option C. Store the data in cloud storage and use lifecycle management to delete files when they expire. Explanation of why option C is correct. Cloud storage lifecycle management provides a highly efficient and automated solution for securely retaining data and ensuring compliance with regulatory requirements. 1. Automated deletion. Lifecycle rules allow you to define policies to automatically delete data after a specified retention period, eliminating the risk of human error and ensuring compliance. 2. Regulatory compliance. You can configure retention policies to enforce a minimum retention period before data becomes eligible for deletion. 3. Security. Cloud storage ensures data is encrypted at rest and in transit, aligning with healthcare data security requirements. This solution is cost-effective, reliable, and aligns with Google recommended practices for data lifecycle management. Analysis of other options. Option reason against. Manually deleting records is error-prone, labor-intensive, and not scalable for handling large datasets or ensuring compliance with retention policies. B. Anonymizing data with the Cloud Data Loss Prevention API does not fulfill the requirement to delete data when it expires and may not meet compliance requirements. D. Running nightly batch scripts adds complexity, increases operational overhead, and is less reliable compared to lifecycle management policies. Conclusion. Option C is the most efficient and compliant approach for securely retaining and automatically deleting data based on a predefined retention policy, ensuring the company meets regulatory and corporate requirements without additional operational burden. Question 99. You are deploying a PHP App Engine standard service with Cloud SQL as the backend. You want to minimize the number of queries to the database. What should you do? A. Set the Memcache service level to dedicated. Create a key from the hash of the query, and return database values from Memcache before issuing a query to Cloud SQL. B. Set the Memcache service level to dedicated. Create a cron task that runs every minute to populate the cache with keys containing query results. C. Set the Memcache service level to shared. Create a cron task that runs every minute to save all expected queries to a key called Eurocached_query0. D. Set the Memcache service level to shared. Create a key called Eurocached_query0 and return database values from the key before using a query to Cloud SQL. The best approach is option A. Set the Memcache service level to dedicated. Create a key from the hash of the query, and return database values from Memcache before issuing a query to Cloud SQL. Explanation of why option A is correct. This option ensures you minimize the number of database queries by leveraging caching efficiently. 1. Dedicated Memcache service. A dedicated Memcache instance provides better performance and is specifically designed for high-throughput caching, which is important for reducing the load on Cloud SQL. 2. Hash-based keys. By hashing the query, you can generate unique cache keys that correspond to the result of specific queries. This allows the application to check the cache first before querying Cloud SQL, effectively reducing redundant database queries. 3. Optimal caching. By caching the results of frequent queries, you can significantly reduce the number of times your app accesses Cloud SQL, thus improving application performance and lowering the cost of database operations. Analysis of other options. Option reason against. B. Population the cache with queries via a cron job does not dynamically adjust to query frequency or application usage patterns. Caching should be dynamic based on actual queries. C. Saving all queries via cron job into the cache introduces unnecessary complexity and will result in redundant or outdated cache entries. It's inefficient and less flexible. D. Using a shared memcache service is not as performant as a dedicated service for high-throughput caching, and static caching via a single, cached_queries, key is too broad and inefficient. Conclusion. Option A is the optimal solution because it uses a dedicated memcache service and dynamic query-specific caching, ensuring efficient and scalable caching while minimizing the number of database queries. This approach follows best practices for optimizing application performance with Cloud SQL and Memcache. Question 100. You need to ensure reliability for your application and operations by supporting reliable task scheduling for compute on GCP. Leveraging Google best practices, what should you do? A. Using the cron service provided by App Engine, publish messages directly to a message processing utility service running on Compute Engine instances. B. Using the cron service provided by App Engine, publish messages to a Cloud Pub subtopic. Subscribe to that topic using a message processing utility service running on Compute Engine instances. C. Using the cron service provided by Google Kubernetes Engine, GKE, publish messages directly to a message processing utility service running on Compute Engine instances. D. Using the cron service provided by GKE, publish messages to a Cloud Pub subtopic. Subscribe to that topic using a message processing utility service running on Compute Engine instances. The best approach is B. Using the cron service provided by App Engine, publish messages to a Cloud Pub subtopic. Subscribe to that topic using a message processing utility service running on Compute Engine instances. Explanation. This option aligns with Google Cloud best practices for reliability and scalability in task scheduling. The App Engine cron service is a fully managed and reliable tool for scheduling tasks, avoiding the operational overhead associated with managing cron jobs on virtual machines or Kubernetes clusters. Cloud Pub Sub provides a decoupling mechanism between producers and consumers, ensuring reliable message delivery and automatic scaling to handle workload spikes. Compute Engine instances can subscribe to the Cloud Pub subtopic, enabling the message processing utility service to handle tasks in a reliable, scalable, and on-demand manner. This design promotes separation of concerns, reduces operational complexity, and ensures fault tolerance. Analysis of other options. Option A, which involves publishing messages directly from App Engine cron to a Compute Engine service, lacks the benefits of Cloud Pub Sub. Without Pub Sub, there is tight coupling between the scheduler and the processing service, reducing reliability and scalability. Option C suggests using the cron service provided by GKE to publish messages directly to a Compute Engine service. This approach ties task scheduling to Kubernetes, increasing operational complexity due to the need to maintain and manage Kubernetes clusters. It also lacks the decoupling provided by Pub Sub. Option D uses GKE's cron service and integrates Pub Sub for decoupling. However, it introduces unnecessary complexity by using GKE for scheduling, which requires managing Kubernetes clusters. App Engine cron service is a simpler and more effective solution for scheduling tasks without the overhead of cluster management. Conclusion. Option B is the most reliable and scalable solution. It leverages managed services like App Engine cron and Cloud Pub Sub, minimizing operational complexity while promoting decoupled architectures. This approach is the most efficient and aligns with Google Cloud's recommended practices for task scheduling and message handling.